Hey guys, welcome to chapter 7, which is momentum. So this is actually a very interesting chapter because I find that it's very applicable to real life. Most of the times when I try to think physics in everyday life, I end up thinking momentum because it's very applicable. So now, your book says by momentum we mean inertia in motion. So we remember we defined inertia. So let's just define momentum really quickly. Inertia, sorry about that, in motion, and inertia, we'll go back to chapter 3, is the tendency of an object to keep doing what it's doing. Keep doing what it's doing. So that kind of makes sense, right? Because when we think momentum in our brains, before our physics knowledge, we think, yeah, if you have a lot of momentum, you're gonna keep going. You're just gonna keep going. It's gonna be harder to stop you, and that makes sense because inertia. If you're a moving ball going this way, if you have mass, you have inertia. You want to keep rolling, so it's gonna take an opposing force that's greater than the rolling force to stop you from moving. So that's how momentum and inertia are intertwined, and they're very close relationship. And now we have an equation to actually define momentum, and it's a very simple equation, and it makes sense logically. Momentum is equal to mass times velocity, or mv for short. So if you see, momentum is equal to mv. But remember velocity, so this is basically our main equation, right? But velocity is a vector. If we're talking scalars only, it's just going to be very simple. Momentum is equal to mass times speed, basically the same thing, except velocity is a vector, speed is a scalar, right? But that you don't need to concern yourself with that detail. But let's work through a problem. Find the momentum, this is just off the top of my head, of a 15 kilogram truck moving, this is probably an example of the problems you might see on your homework and whatnot, moving at 10 meters per second. Okay, so let's identify, we have a velocity, right? And we have 15 kilograms. We have our mass. So it's going to be very easy from now on. So momentum, I'm going to abbreviate it, mom, M-O-M, mom, is equal to, let's plug in our mass, 15 times 10. We have momentum is equal to 150. Okay, right? So 10 times 15, right? Yeah, makes sense. So, and it's actually the very weird, units for this, but it would be kilogram meters per second, right? Just because we have kilograms meters per second, none of those can cancel out between each other, so it's 150 kilograms per meter second. Now we're going to talk about changing momentum. So let me clear the slate here. Clear. Give me a second. The black screen is much better than the white screen. So now when we don't talk about changing momentum, we talk about a term called impulse. Changing momentum. And when we talk about change, from now on I'm going to use delta, which is just a simple little triangle, which in science means change. Shade it in a little bit. Okay, so now we talk about an impulse. You kind of know what the word impulse means. It kind of, in everyday speech, it's kind of like a push or a force. You kind of may think of as impulse as a force, like a big blast or something like that, like the impulse of the car hitting me. And that's basically what it is. But it's something that changes momentum. So it has to be a force. So impulse is always a force, right? And basically, well, it's not so much a force, but it has components of force within it because it needs a force to change the momentum. So it can either increase momentum, or decrease momentum, right? Simply because it could make an object move faster or make an object move slower. That's that, to put it very simply. So now we do have an equation for this as well. It's impulse, sorry, is equal to force delta time. Now you might be freaking out. Oh, I've never seen a delta in an equation before. I've never seen change. It might be a little scary, but look back up here. Change. Okay, delta means change. Because we know that when we're dealing with impulse, well, we don't know, but I'm about to tell you, when we're dealing with impulse, the longer time that there is, like the larger the time quantity this is, so basically if you think that the larger the time is, there's the less change, the more change in momentum there is. I'm sorry, I'm having trouble talking today. So, okay, let me just start over. The higher time it takes for the impulse to do its job, to change the momentum, the more the momentum is going to change, basically. So, if your time quantity is very big, I'm going to draw a big T, okay? The momentum is going to change a lot, a big change. Because, so let's think of this. If you're getting punched in the face by a boxer, professional boxer, and you have no defense against him, and he's just going to punch you right in the face. This is actually on page 89. What would you want to do? Would you want to move your head back or forward or keep it where it is? Well, I would want to move my head back and kind of roll with the punch. Well, why is that? Because that actually increases this time. That makes the time shoot up because it's taking more time for this interaction between his fist and my face. So the momentum of his fist is going to change a lot more. The momentum is actually going to decrease. And so therefore the force is going to be a lot smaller and I'm going to get hurt a lot less. But if the time were kind of small, if it was just one quick punch to the face, the force would be really big. So think of it like this. Big time, little force. Big force, little time. That's key to remember, okay? And these are T's, not 6's or F's. I draw my T's with this little tail at the end. I have no idea why. Sorry for the beginning of this explanation where I was not really talking correctly, but it's kind of late at night. But yeah, think that when the time goes up, the change in momentum, the momentum is higher. So we talked about over here that it can either be an increase or decrease. So with our punching example, with the man punching us in the face, that would be a decrease in momentum, right? Because the more time. But let's say you're giving a car a push, like you're trying to push a car. Well, the more time that it takes for this impulse to occur, the more momentum the car is going to gain. If you just do one quick push, it's not going to gain very much momentum, okay? And that's the gist of the impulse equation, and that's the gist of the first part of Chapter 7. So I'll see you guys in the next video when we talk about increasing, decreasing momentum, as well as bouncing, and maybe we'll get into some collisions, which are very neat. So I will see you guys in the next video.